Hello. Welcome. Can everybody hear me? Good. I do apologize. I have a little bit of a cold, so bear with me on that. But I'll try to do as much talking as I can without losing my voice here. So, who am I? I'm just some guy. I do pen testing for fun and for work. I also believe that supporting our community is an important thing, right? So I volunteer with ThoughtCon, volunteered with DEF CON for, this year will be my 19th year. Also doing Tour Camp out in the middle of the Puget Sound. It's a hackers camp. It's pretty fun. Also try to help with the local DEF CON group, right, as much as I can. It turned 10 this year, I think, which is pretty cool. And I also believe that we should have options for our ISP. So I started a Pico ISP up in Minnesota because screw the big companies. And yet I work for one, which I never would have thought I would. But I do, and it's pretty fun. So now on to our main topic.
Developers.
It's kind of crazy. We've brought a bunch of people up to be developers. Unfortunately, we've forgotten a lot about security. And even in development programs, security is not the forte, right? It's get code out on a deadline before you miss your deadline, because if you don't get code to roll, you lose money, which is unfortunate but true. So stuff is all messed up. There's a couple of stories in here in this presentation. First one is about gaining access to 1.2 million credentials, which is, for me personally, the biggest find of credentials that I've done. One of the things that I often see when we're doing reviews or when we pick up code, I'll see someone say, oh yes, we encrypt the credential, we encrypt the password. Unfortunately, encryption is not hashing, or hashing is not encryption. It's a one-way function. You can still take data and hash it in a one-way method and compare it. Encryption is being able to pull that data back out if you have the right key. Hashing, you won't be able to pull the data out. You have to compare the data. But it's not encryption. Shouldn't be used that way. Shouldn't be taught that way. I'm going to define a couple of terms here. First one is MD4. Considered broken in the 90s. MD4 is what Windows uses, right, for NTLM. Right? When it stores your credentials on disk in a domain controller, it's an MD4 hash. It's awful. With cloud computing systems, you can get 68 gigahashes per second. That's with 8 K80s. That's pretty bad, because I have more statistics later on. All right, let's talk about SHA-1. SHA-1 was a secure hashing algorithm 1. Right now, it's no longer considered secure, just based on the fact that with GPUs, you can also brute force it. It's not quite as fast as MD4, right? We're talking about 14.8 gigahashes per second, or billions of hashes per second, on 8 Tesla K80s. All right, so let's talk about bcrypt. Bcrypt is a much stronger hashing algorithm from the perspective that it has to go through multiple rounds. And the multiple rounds add extra entropy, add extra time, really is what it comes down to. Extra time to cracking hashes or brute forcing password hashes. As you can see, 15.2 kilohashes per second. It's an order of magnitude slower to do brute forcing of bcrypt. So let's talk about if I ran the dev zoo. Particularly, where do you store your keys, right? Do you store them in a box? Do you store them with a fox? Do you store them on an open NFS or SMB share? On Git, if you dare. No, seriously, on Git. These are private keys. They're all the same private key, but it's multiple developers that have checked the private key in to their GitHub account. In this case, it's an enterprise GitHub repo, which means that all 300,000 users in the organization had access to these keys, which I could then reuse and gain access to all of their boxes. And that because they didn't use any sort of encryption or password on the key, anybody could load them up and use them, reuse them. It's pretty bad. I don't know if you can read this in the back, but the quote is basically, when you're wrestling for possession of a sword, the man with the handle always wins. This is a quote from Snow Crash by Neil Stephenson. If I've got the SSH key, game over. I always win. It's a physical key. Used to be passwords, right? If I had the password, game over. People have moved away from passwords and are now using SSH keys, which is great, right? It's the right step. It's the right direction. However, what ends up happening is people copy these SSH keys onto intermediary servers or out onto servers that they probably shouldn't have, like their GitHub repo, for example. And we often find SSH keys stored in Jenkins configs and OpenNFS file shares, SMB shares, home directories of Unix file systems, even exports of home directories on Unix file systems, and application configs. Oftentimes we look for ID star or star.key or star key in any file system that we're on. And we find these things. It's pretty crazy. The other thing we find is we'll find SSH keys stored in VM images. A lot of times you'll boot up a VM, work on it, shut it down, and then transfer it off to one of your network resources so you can share it with a coworker. Well, unfortunately, these VMs will have keys, they'll have private keys, they'll have password hashes. And we pull both of those off the VM, just remount it remotely on the network. There's many tools that you can use to just mount a loop file system and pull those password hashes or keys off the box. Works pretty well. I've seen it a lot with NAS systems. Like someone will set up a NAS that a department uses to share images between developers or between people, and then they forget to put a password on it. Or they have the default password on the NAS, and now, lo and behold, you've now gained access to their systems because of it. So I think the biggest takeaway is people need to learn to use SSH agents and forwarding. So SSH agent loads your private key into memory and then can only be utilized from your machine, your local machine. And then forwarding will take and open up a port to the remote host to forward your agent authentication all the way out to the server that actually needs to talk to your agent. So you're never moving a key. You're only creating a session, an ephemeral session for the time that you're using it. It makes it a lot harder for someone like me to reuse your session or reuse your agents, right? And reuse your private key, really, which is what I care about. Otherwise, you get access to lots of these. We also had a system where we're able to access 96 production machines because we got access to an SSH key, private SSH key. It was the root key shared amongst all the systems. Also had a NFS share where they had all of their EC2 keys shared in folders with the IP address right next to them. So I could walk through all of the folders and recover the keys and then log into all their EC2 instances. Once I'm there, they're running a database on that. I can go and log into the database and start dumping all of the data out of the database. So if you think about it from a DevOps security perspective, you need to not just protect the production environment, you also need to protect the development environment and make sure that people aren't leaving this stuff around. There are a lot of vaulting systems, for example, that will allow you to put these keys in the vault and then only check them out when you need them at the point of use. All right, so let's go back to 1.2 million credentials. Step one, find open access, right? In this case, one of the things I found was an open NFS share. On the open NFS share, we had what's basically a kickstart file. If you can see, username, root, password, root me. Okay. I tried that password, tried that combo on a bunch of machines. Didn't work. So basically a dead end. Okay. Well, also saw there was an IPMI service available on about a dozen machines. IPMI is basically lights out management for a bunch of super micro servers and a whole bunch of other servers. It's very useful if a machine is down and you're trying to, rebuild it or get to it. However, the security on these IPMI instances is awful. Awful from the perspective that you can dump the hashes on the machine just by talking to it. It supports, basically null cipher. So you can go through and tell it, hey, I want to talk to you, and dump all the hashes. I found, I think it was one or two of these servers that had a default password on it. Unfortunately, I didn't want to cause an outage. I wanted to be stealth, right? That said, I have in the past, with permission of the client, rebooted the machine, mounted a Linux USB drive remotely on the system, dumped the SAM, and then gone back and replayed the hash at the machine and logged in, and then used Mimikatz, right? So that is a whole nother avenue of attack. It's totally legit. All right, so let's go back to step one. Find open access. In this case, in the development environment, we found a Jenkins server. Jenkins, in this case, was not set up to use any sort of authentication. Does anybody know what Jenkins is? Okay. So for those of you who don't know, it allows you to build a package and then push it to your production environment. It's kind of nice from that perspective, right? Gives you a little bit of automation. But by default, it didn't come with a username and password login. So you could just go right to the console and start pushing packages. Gets better. There's a scripting console. And literally, you can go to the scripting console, and this is just running ls, right? We're running ls as the Jenkins user in a shell. And we get output down here, list of files that come out of it. Well, what you can do is you can create a redirect to netcat. So netcat is neutered on this machine, doesn't allow you to do the -e, but you can create a named pipe and then redirect your shell output to the named pipe, and lo and behold, you get a netcat listener or a reverse shell on your system. And this is the build server, right? Jenkins at build server. Now, usually what I do, once I get access to these machines, is I start looking around. What is out there? What trust relationship does this machine have access to? In this case, I found a .NET RC file. At the time that I found it, I was like, I don't know what this is, but there's usernames and passwords in here. This is good stuff. Okay. Anyone here use Git? Okay, I hope everybody here does. I use it. It's very useful. It's also useful when you have credentials that are for the Git server. So in this case, .NET RC, was GitHub credentials. And I didn't really realize that. I just tried it. As you do when you kind of do YOLO pen testing. But gained access to the GitHub repo as an internal repo for the code. In the repo was the username and password for the database, right? I think this was their test database, but it also had the production username and password for the MySQL database. But it gets better. They actually checked in production administrator accounts for things like Mailgun into the code. So now all I had to do is go log into Mailgun, and I could dump anybody who they've ever sent email to. Or I could send email as the admin to anybody they've ever sent email to. They also checked in their payment gateway username and password, APIs, everything. It was not good. So now that I've got the MySQL password, now I'm going to go dump the database, because that's really what I'm after here. And so, yeah, it might be hard for the people in the back to read this. I apologize. But it says username, user password encrypted. Wait a minute. Didn't I just say we shouldn't be calling passwords encrypted? They're hashed, right? So if we look in the database, looks like there's a timestamp, username of admin, some sort of gobbledygook, which looks like a hash. Oh, and that looks like a hash. Wait a minute. I'm going to guess, dollars to donuts, that the user password was not hashed when they first put this app together. And someone came in and said, no, you can't do that. You have to have encryption. And so then they added the user password encrypted. And maybe somebody else came along and said, no, it needs to be hashed. So they hashed it without any salt, without any thinking. Anyway, it's frustrating. So now I went through, counted all the lines in the file. We got 1.23 million records, million lines, which is pretty awesome. I don't know if has anybody been to DEF CON? This is one of the pool parties at DEF CON, which is how I kind of feel. Like, hey, fun time for me. 1.2 million accounts. Of those 1.2 million accounts, 820,000 of them had SHA-1 hashes stored next to them with no salt, right? So no salt means that anybody who's got the same password that's the same is going to be the same hash in the database. So it was at this point, we basically were spending $2,000 to $3,000 a month on cloud-based services to do password cracking. And I said, this is ridiculous. We could save ourselves $1 million over the next 5 years if we just build it ourselves. So we did. We call it the Kraken. It's two units with 8 GTX 1080 cards in it. It's got a whole boatload of memory. Basically, we use the rack expander units just for air cooling and the fact that they have really beefy power supplies. I built a couple of these in shitty one-off hardware things that are a couple $100 from Amazon, and the cards usually fail or the power supply fails, and it's no fun to try and troubleshoot that from 500 miles or 1,000 miles away. So we actually spent a little money on the expander so that we have all of that built in. All right, so we talked about our cloud controller, cloud computing. This is bcrypt versus one of our nodes, 8 GTX 1080s. One of the nodes can do basically a factor of 10 compared to what a cloud GPU can do, which is pretty crazy. Same with SHA. SHA-1 we go from 14 gigahashes on a cloud system to 66 gigahashes per second. And then if we want to talk about MD4 or NTLM, we're talking, 334th gigahashes per second. It's just insane. To give you an example, we can brute force a 7-character password on this in under 3 minutes. An 8-character password all in takes us 12 hours. All right, so now let's go back to our database dump. What I want to know is who on the system is using the same password. So I rounded up the top 1,000 collisions and then basically ran a brute force, right? In this case, I did 8 characters, all in. Out of the top 1,000, 997 of them actually loaded. Of those, I was able to recover 907 hashes, or passwords of the hashes. And here's the top 1,000 collisions. So this is what happens when you have a web app that doesn't have any sort of password requirements, right? And that the web app didn't say, please use a secure password. It didn't say, you can only use such and such. Do not use dictionary words. And so the user just does 1, 2, 3, 4, 5, 6, or password, or QWERTY, right, which is a keyboard walk, or ZAQW, right, 1, 2, WSX, right? These are the patterns that we see when people are left to their own devices to make passwords up. 1, 2, 3, 4, 5, ABC 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 1, 1, 1, 1. So then I took this same set and I added a digit to the end. So basically we could get nine positions. Next one was 1, 2, 3, 4, 5, 6, 7, 8, 9. Super original. And then password 1, QWERTY 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, password 1 with a capital P. So now this meets most of Active Directory's requirements for complexity, which we find quite a bit when we do pen tests. It's pretty bad. It was about a year ago. I was doing a pen test of a company that had sequential user IDs that were numerically sequential. I found that they had like a time portal, Outlook web access, and some other system. They were all available to the internet, all back-ended to Active Directory. I first used the OWA portal to sort of identify users, and that was really slow. I then used their, I think it was like a timesheet application to test passwords. That was much faster. The OWA took about 12 hours. I think their time app, everything came back in about 45 minutes. And that was rotating through, 11111 as the username, and then password of, I think at that time was fall 2017. And actually I did fall 2017 exclamation point. I got 2 users off that. I then decided, well, let's take the exclamation point off. I got 35 users, and I think 2 of them had access to the mainframe. So, I'm overthinking this stuff, clearly. All right, so what do we do to fix this, right? We have to educate developers that they shouldn't be treating their private keys so carelessly, right? Make sure they don't check them in. Don't leave them lying around. And encrypt them. I think that's the hardest part, is people don't realize that your key is worthless if you don't have a password on it. You should definitely put a password on the key and make sure that you're only using it on your local machine, and then you're requiring SSH forwarding to forward that authentication agent out. Another thing is do security testing. There are a lot of companies that think, oh, well, we can have, Joe Blow in the development group find stuff for us, and then we'll get it fixed, and we'll be good, right? And I don't think that works. Well, there's a couple of cases where I know it doesn't work. Do code reviews by experienced professionals. And the other problem that I see all too often is they'll do the security testing at the end before it goes to production, and should actually be integrated into the dev cycle so that you can catch it. It's much cheaper to fix a bug at the beginning of version 1 than it is to fix a bug at the end when it's about to be shipped off for production. So it needs to be cyclical. And so one of my coworkers, he and I were talking. He worked for a software development company for a while. And one of his coworkers found a bug in their software. And it got added to their bug tracking system. And at some point I believe they had some auditors coming through. And they decided to just remove the bug from the bug tracking system versus fixing it, right? So this is what happens when you have people who are in your direct reporting line do security, is they get overruled by management. So, unfortunately, you kind of have to have someone outside of your security chain, outside of your reporting structure, actually do the work. All right. I think I'm about done with time here. Anybody have any questions? I think I have time for one.
So that SSH agent forwarding, is that something that's local on your machine, or is that a remote machine that you're getting to, or is that going on?
All right, so SSH agent forwarding. It's local to your machine. You should be loading the agent on your machine, and that loads the key into the agent. And then what you do is, in the actual SSH config, you can tell it to forward the agent to the next hop that you're going to. And then on that machine, it can forward the agent out to the next machine, and et cetera, et cetera. So the agent is only available at the time that you need to do the authentication. All right, thank you.